Sass Class with Amanda. Hey! In this video, we're continuing our introduction to probability. We'll be working through a few examples in which we'll describe a probability model and state whether an assignment of probabilities is legitimate. So through that example, you'll also be learning what does a legitimate probability model mean. So here we have two dice. I've only drawn one. You want to determine the probability that you'll roll a 7. The sum of the numbers face up. Okay, so we're looking at two dice, and we want to figure out the sum of the two numbers when they're face up. So our sample space is all possible outcomes. Okay, so S is going to be the set. So what's the minimum sum that we can get? Well, that's 2. Okay, the next sum that we could get is 3. So we don't list repetitive sums here. This set is going to be the smallest, the smallest possible set. And then we'll talk about frequency. So how frequently would 3 appear? How frequently would 4 appear? That happens with the assignment of the probabilities. Okay, so 2, 3, 4, etc. And so what is the largest sum? Well, 6 plus 6 is 12. So it's every integer between 2 and 12. How many possible outcomes are there? Well, again, now we want to take frequency into our consideration, because it's not just 2 through 12, which is just 10 possible outcomes. We want to think about how many of each of these can occur. So 2 only happens when we have 1 and 1. Okay. 3 can happen when we have 2 and 1, and then 1 and 2, right? So how many possible outcomes are there? Well, we have 6 possibilities for the first dice or die, and then 6 possibilities for the next die, and so that tells us we have 36 possible combinations, okay? What is your event? Well, we know an event is a particular outcome, and based off of the description of this problem, we know that this event is getting a 7. So roll a 7. And we want to think about how many different ways can we have a 7. Well, we can have a 7 if we do 3 and 4. We can have a 7 if we do 2 and 5. We can have a 7 if we do a 1 and 6. But remember, this is the first die, and this is the second die. So we're not told that order matters. So we can also look at it 4 and 3, 5 and 2, 6 and 1, and so we have 6. And so determine the probability of this event. Well, 6 is the total number of ways we could get 7 out of 36 possible outcomes, which tells me that the probability of rolling a 7 is 1/6. What is the probability that this event does not occur? Well, we take advantage of rule number 4, and that's just 1 minus the probability of A. Okay, and so that tells me this is 5/6. If you have any questions about what we did in this problem, you should probably write them down now and bring them into class, okay? All right, this next example. All right, so in each of the following situations, state whether or not the given assignment of probabilities to individual outcomes is legitimate. That is, satisfies the rules of probability. Okay. So legitimacy means it has to satisfy the rules of probability. Remember, probabilities have to be between 0 and 1. Okay? And the entire sample space has to equal, the probability of the entire sample space has to equal 1. Okay? So if we roll a dice and record the counts, or the count of spots on the up face, so we have 1 die here. Okay? And we're looking at the spots on the up face. So we have 1, 2, 3, 4, 5, 6, etc. So notice that each of these outcomes is not 1/6, which tells me that this die is not fair, or not intended to be fair. If it was a fair die, it would be 1/6 for each of them. but it's not. So that tells us it's a little bit loaded. All right, so all of these values are between 0 and 1, so great. The first rule of probability is satisfied. All right, so each of these is also disjoint. Okay, so either you get a 1 facing up, or a 2 facing up, or a 3 facing up. So the probability of getting a 1 or a 2 is the probability of 1 plus the probability of 2. That's not really like a rule that you want to check. That's just a rule that you use. So there is a difference between the 4 rules we stated in one of the other videos. 2 of them are rules that we want to check, which are the first 2, that every probability is between 0 and 1, and that the sum of the probabilities is equal to 1. The other 2 rules are the ones that we want to use to calculate probabilities of events. Okay, we're not going to use those here. Now, since we can see that all of these are between 0 and 1, what we want to do is make sure that these all add up to 1. So I'm just going to leave this as a 0. This is 1/6, so this is 2/6, this is 2/6, this is 1/6, and that's a 0. So 1 plus 1 is 2, 2 plus 2 is 4, plus 2 more is 6. So this tells me that the sum of these is equal to 1, which tells me that this is a legitimate probability model, or that the assignment of these probabilities is legitimate. Now we want to do the same thing for the next model. Alright, so we see that everything's between 0 and 1, so the first one is satisfied. Now what we want to do is check to see whether these are equal to 1. Alright, so we'll start with the first 2. 0.56 plus 0.44 gives me 0, carry the 1, 9, 0, 1. And so just adding up the first 2 has given us 1, which tells us that adding 2 more is going to make it greater than 1, which tells me that this is not legitimate.
My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. We live in a world of technology. They're collecting information on your humanity. Social networks, gaming, and in-home software.
Hello, Alexa.
Statistics helps us be more aware. Haters gonna hate my spicy lyrics. Why you gotta be so mean? Pulling me towards your extreme moods, but the median never fails to center me. 50 to my left, 50 to my right. Got these correlation and regression tools, forget them fools. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. My name is Llama, and I'm here to teach you stats, skilling you up with them cold hard facts. The mean of the means is the mean. The mean of the means is the mean. The mean of the means is the mean is the mean of the means is the mean is the mean. Be careful not to fall in love. Statistical seduction from above. Your shape so beautifully symmetric to the eye with a single peak so high. I hypothesize and can testify that your p-value is the smallest I've seen. Mix that with a large power and I reach ecstasy. Your residuals defy the rest. A small scale randomized pattern tells me you are the best fit. My name is Llama, and I'm here to teach you stats, skilling you up with the cold hard facts. My confidence is so high, 95%. My margin of error so narrow, 1/10. Can you feel me? Can you feel me? I estimate your population parameter based on only one sampling. Oh, haven't the frequentists told you about me? We live in a world of data, attempting to understand life by statistical strife. The implicit bias of cops, success rate of them jocks, medical advances, and AI romances. Statistics.